Hi guys, my name is Cristian, I'm from Coslada, Spain, and I'd like to look a bit further in the way condenser and dynamic mics work, trying to understand why are they different both in terms of sound and recording applications. As Lawton said, all microphones are transducers, meaning that they convert sound energy into electrical energy. The efficiency of this conversion is quite important because the sound pressure, the acoustic energy produced by voices and musical instruments, is in fact quite small. Both dynamic and condenser mics use a moving diaphragm to capture the sound. What makes a difference is the electrical principle for converting the sound pressure, that is basically mechanical energy, into an electric signal. So, how do they work? Let's begin with dynamic mics. Dynamic microphones operate by electromagnetic induction to generate an output signal voltage. This is basically like having a very little loudspeaker working in reverse. In dynamic mics, a lightweight diaphragm, usually made of plastic film, is attached to a coil of fine wire. This coil is suspended in the air gap of a magnet, in a way that it is free to move back and forth within the gap. When the air pressure caused by the sound wave strikes the diaphragm, it vibrates in response. The coil attached to the diaphragm moves back and forth in the field of the magnet. As the coil moves through the lines of magnetic force in the gap, the whole thing works the same way an electricity generator does, and a small electrical current is induced in the wire. The magnitude and direction of that current is directly related to the motion of the coil, being an electrical representation of the sound wave. As Lawton said, dynamic microphones are tough. They don't need a power supply or batteries to work, and they are cheaper than condenser mics. Still, why do people pay thousands of dollars for a condenser mic when you could get a Shure SM58 for $100? This reflection takes us to the major drawback of dynamic microphones. The air pressure or sound energy has to move not only the mic diaphragm, but the wire coil attached to it as well. Due to the mass of the moving coil, the transient response of a dynamic mic is less sensitive on the average than the condenser mic, failing to reproduce very high frequencies accurately. This may be no trouble at all for some applications, but for instruments with a lot of tonal detail in the upper harmonics, a dynamic mic won't be able to bring out the best of it. And that's not all. Because of the heavier mass of the diaphragm and coil assembly, the dynamic microphone is quite inefficient, meaning that a lot of amplification has to be used to make the signal usefully large. And remember that the more gain you use, the more noise you add to the signal. When the mic is used very close to the sound source, this lack of efficiency is not really a major problem. But if you're trying to capture a quiet or very distant sound, something subtle, then a dynamic mic won't probably be the best choice available. Now, let's move on the other major microphone type, condenser ones. The diaphragm of a condenser microphone is a very thin plastic film coated on one side with gold or nickel and mounted very close to a conductive stationary backplate. The diaphragm and backplate, separated by a small volume of air, form an electrical component called a capacitor, also known as condenser. This capacitor needs a polarizing voltage in order to work. That's the 48-volt phantom power source Lawton mentioned on his lesson. The term phantom comes from the fact that this polarizing voltage is supplied via the signal leads of the microphone, so no additional cabling is needed. When the spacing between the plates changes, as it does when the diaphragm vibrates because of the sound wave, the capacitance changes as well. This means that when the diaphragm vibrates in response to a sound, it moves closer to and farther away from the back plate. As it does so, the electrical charge that it induces in the back plate changes proportionally. The fluctuating voltage on the back plate is therefore an electrical representation of the diaphragm motion. Because the diaphragm of the condenser is not loaded down with the mass of a coil, it's very light compared to that of the dynamic mic. So the system is more efficient in turning acoustic energy into an electric signal than dynamic mics, having a much greater frequency and transient response. They also generally have a louder output than dynamic mics, but are much more sensitive to loud sounds. The capacitor principle, unlike the dynamic principle, allows the production of mics with different switchable polar patterns. To achieve this, the capsule is made with two diaphragms, and by changing the level and polarity of the polarizing voltage on one of the diaphragms, every possible polar pattern can be created, from omni through cardioid and hypercardioid to the figure of 8. The size of the diaphragm also has an effect on the tonal quality of the mic, being said that large diameter models provide a warm, flattering sound, while small diaphragm models tend to be more accurate. And that brings me to the conclusion of this assignment. I hope it's been useful for you and maybe shed some light on the reasons why dynamic microphones are most effective when working with relatively loud sound sources that don't contain a lot of very high frequency detail, while condenser microphones, even being more expensive than their dynamic counterparts, are also much more sensitive and can capture high frequency detail much more accurately. Thank you for hearing.